Welcome to IEC Energy by HMS Networks. Let's have a look at the SG Gateway's IEC 61850 settings and how this energy protocol is handled by the SG Gateways. For more details on IEC 61850 and the IEC 61850 communication methods, HMS will provide more videos and white papers. This video will focus on how to get started. IEC 61850 is an energy protocol that supports quality and timestamps with milliseconds resolution using UTC. It contains a whole bunch of protocols and standards, integrated to one big thing to include all kinds of solutions for any grid communication topic. For example, there are 3 ways for transmitting data included. One, called polling, is easy to configure but inefficient. The second one, named reporting, is efficient. And the third one, named Goose, offers hard real-time communication but can be more complex to configure. For using polling or reporting, there are 2 roles, server and client. The server is the device that provides or receives the information, usually the IED, Intelligent Electronic Device. The client can be a local controller, gateway, or a control room, asking for data and sending commands. A client can control multiple servers. The SG Gateway can run the server role and the client role at the same time. This role is named both. The server can be connected and controlled by up to 16 clients. The client can connect and control up to 32 servers. Please note that due to performance limitations, the number of logical devices that can be connected to the SG Gateway in client mode is limited to 32 logical devices. For example, the SG Gateway in client mode can handle 32 servers, each with 1 logical device, or it can handle 8 servers with 4 logical devices each. Configuration of devices in IEC 61850 networks is done by so-called SCL files. SCL stands for Substation Configuration Language. SCL is just a file structure using a clear-type text file with XML format. It also defines rules of naming and numbering. Any SCL file can be opened and modified using any text editor like Notepad++. Of course, there are many specialized SCL editing tools available as well. SCL files come with many different file type endings for different use cases and meanings, depending on the step of configuration. The IEC 61850 settings are mostly configured in a CID file, which configures a single device like the SG Gateway. CID stands for Configured IED Description. This CID file can be imported using the Settings tab in the 61850 section. A CID file for configuring the SG Gateway to act in client role is a little bigger than the CID file for server role, since the file includes information for the client but also for the connected servers. If the SG Gateway in client role shall connect to more than 1 server, please feel free to contact HMS Technical Services for assisting you with the merging of those several CID files. Please download the 2 sample configuration files for IEC 61850 from ixat.com/energy. You can use the files to reproduce the next steps on your own SG Gateway. The sample files include commands for more insight. Let's start with the simple server role configuration. Using a CID file you might get out of your configuration tool, from your ID configuration specialist or a service from IEC. Important is that the CID file states 0000 as IP address. This can be easily checked and updated using any text editor. Using this IP, the server can use any available Ethernet interface of the SG Gateway. For limiting a server configuration to a specific Ethernet interface, the built-in firewall of the SG Gateway can be used. For network settings, please see our additional video and manual. Now access the SG Gateway's web interface and continue to the IEC 61850 settings page. Select Server as role and import the CID file. To activate all data points for later use, simply click the button Select All. For files with a large amount of data points, we recommend selecting only the relevant data points for better performance. To do this, expand the tree of data points and activate the desired data points by clicking the checkboxes. For using Opera data points, who are the data points used in controlling direction, please see our dedicated 61850 commands video or the Getting Started of the SG Gateway for more details. Debugging options will report to the event log. Finally, click the OK button to save your settings and reboot the device to initialize the selected data points in the Web PLC editor. To use the SG Gateway in client role, some extensions are needed, as a client is using its own IP settings and IED block, but also needs to import the configuration of one or more servers. Let's show this case based on a protection device, in our case an ABB REF615. This device includes the configuration tool ABB PCM600 and can be connected using the network port on the front with the DHCP. You can also connect it via the rear network port using a static IP that can be configured on the REF615. The tool will show the successful connection. The name of the IED can easily be changed as shown here. When the configuration is complete, don't forget to save, then to use the function Write to IED. Please also export this configuration as CID file. Make sure it contains all details like IP settings and IED name. Editing this CID file with the text editor allows us to modify this for using it on the SG Gateway in client role. Here we can see the device name and IP settings of the server we want to communicate with. Apart from the data of the server, we need to add some data for the client. We need to add the COM block with the IP settings for the SG Gateway itself, and the IED block linked to the same name. If we only need to pull a few data points, which cyclically transmit data every second, then this is all we need to do, and we can save and upload this file to the SG Gateway. To import the client CID file, go to the IEC 61850 settings page in the Web PLC and select Client Role first. Debugging options will report to the event log, as well as connection supervision. Set the polling interval time to 1 second and upload the client CID file. 1 second will be good for processing up to 50 data points. If the file is not too large, you can simply click the button Select All to activate all available data points for later use. Alternatively, you can select each data point manually by expanding the tree of data points and clicking the checkboxes. In our example, we just activate these 3 data points shown here. This will enable us to set a value on the ABB REF615 and watch the reaction. Finally, click the OK button to save your settings and reboot the device to initialize and use the data points for mappings in the Web PLC editor. To finish our little example, let's add the previously shown data points to the editor and set the output to 1 by simply double-clicking its output pin. This one means on for behavior. Now save the program and start the Web PLC. Now behavior is activated once remotely by the SG Gateway, and the ABB REF615 reflects this, as we can see immediately at the Web PLC input. Using the IED Explorer, we can send a command to set behavior to 5, which means off. This is also shown by the Web PLC input block. Polling works fine, good. If polling is not good enough for your application, for example due to low communication efficiency, or simply as polling can be too slow when using many data points, then reporting is the right solution for you. Reporting can be used to replace polling or it can be used in addition to polling. Reporting needs the data points grouped in so-called datasets. Each configured report control block has an assigned dataset. An RCB also contains a set of triggers to define the events for sending content of the dataset. There are 4 types of triggers available: value change, value update, quality change, and cyclic. Cycle time is configured in the RCB's first line above. Since reporting uses a publisher-subscriber relation, we set the allowed maximum of subscribers as limitation on server side, as the server is the publisher. We must insert the following client LN for subscribing to this report into the client CID. Please note that each report control block from the server CID file is loaded and shown in the tree view in separate blocks named report control. Each report control block's dataset name can be found in the sub-element name, and their trigger options in the sub-element trigger options, where they can be modified manually by selecting the desired trigger options. Note that if the Select All button is clicked, all data points and all trigger options are activated, even if some data points or triggers are set to false in the CID file. So, if you clicked the Select All button, recover the report control block trigger settings by deselecting the unwanted trigger options. If reporting is still too slow, Goose can be used, which is really fast. One use case for Goose are alarms. Goose is a specific form of reporting, being a multicast service based on MAC layer communication that uses the predefined triggers, value change, and quality change. A Goose publisher does not know its subscribers. The MAC address of the publisher must be included in the related COM blocks. The MAC address of the SG gateway is shown on the web interface's first page in the section Device Information, or you can use the XAT-Energy IP configurator to read the MAC address. And you also find the MAC address on the product label. In addition, the COM block of publisher and subscriber includes a configuration for each single Goose message, containing the multicast MAC, an app ID, and so on. Well, that's all about SCL files, communication techniques, and data points for now. Let's have a look into the editor to learn about a special mapping topic. Some protocols like Modbus do not support timestamp. So, to provide a complete data point from Modbus to IEC 61850, we might need to use the web PLC to add the missing timestamp. For each Modbus input mapped to an IEC 61850 output, an UTC clock block must be mapped to the output's TS pin to add a timestamp when a value change event occurs. This UTC clock uses the SG gateway's system time, so make sure the device is time synced with your network using SMTP. To learn about how to transmit commands to IEC 61850 servers, please see our additional video on this topic. Thanks for watching. You are very welcome to watch out for more videos.